Hello, Algebra 2 folks, and welcome to Trigonometry, Ratios, and Function. We are going to be studying a trig chapter. And before we do that, we are going to review some much needed geometry skills for you to be successful in this chapter. The first day today, we are going to talk about the Pythagorean theorem and understanding the 30, 60, 90 rules. Then tomorrow's video, we will go into the knowledge of the three basic trig functions, sine, cosine, and tangent, or what you might know as SOHCAHTOA. Okay, so today we're going to focus on the Pythagorean theorem and special right triangles. So you need your notes, a pencil, and a calculator. So trigonometry is the study of the relationship between the sides and angles of a triangle. So here is an example of a right triangle. In order for you to use trigonometry, you do need a right triangle, which has a 90-degree angle. The sides of the right triangle, that are the shorter sides of the three, are called legs, and the longest side, which is across from the 90-degree angle, is always called the hypotenuse. All right, so the Pythagorean theorem is the first thing we're going to discuss today, and that will help us find missing sides of a right triangle when we're given two of the sides. So it's a squared plus b squared equals c squared. The shorter sides of the right triangle are A and B, and the side across from it is the hypotenuse. We call that the C. Okay, so the C is always the longest side across from the 90-degree angle. So if I wanted you to find the length of this hypotenuse of this right triangle, I know it's the hypotenuse because it's across from the 90-degree. I would say 72 squared plus 21 squared is equal to x squared. And when I do that, I would get 72 squared is 5184 plus 21 squared is 441. Add those two together and I would get 5625, square root both sides, and I would get x equals 75. Now it's not plus or minus in this one for geometry because we can't have no negative side lengths. So we won't talk about the negative 75 being an answer, although it's a possibility. The only answer will be the positive. In Algebra 2, the negative would be a possibility, but no negative side lengths when we're talking about geometry. All right, so Randy made a truck for his dog to get into his truck because the dog can't jump anymore. So he made a ramp that's 6 feet long. So the ramp itself is 6 feet long. It touches the top of the ramp to the bottom of the ramp is 3 feet above ground. So we have 3 feet here. It says approximately how far from the back of the truck. So this would be the back of the truck here. This is where I'm not a very good artist, so if I were going to draw a truck here, which I'm not very good at drawing them, this would be the back of the truck here, and then how long is it from the back of the truck does the ramp go touch the ground? So we're looking for this distance right here. So we know this is 3, we know the ramp is 6, and we're looking for this distance. So it would be, this would be our 90 degree, the 6 would be our hypotenuse this time. X would be one of the legs plus 3 squared. So we'd have x squared plus 9 equals 36. Subtract 9 from both sides, we get x squared equals 27. Square root both sides. Again, we can't have a negative side length, so the square root of 27 is 5.2 feet if I round to the nearest 10. And so the answer would be C. This is actually a practice ACT question that I took off of the website. All right, so that is the Pythagorean theorem and how to use the Pythagorean theorem. I'm sure that's a review for most of you. So today we are going to now also talk about those special right triangles. So special right triangles always have to have a 90 degrees. So the first special right triangle we're going to talk about is the 45, 45, 90 triangle. Okay, I'm going to just do a little sidebar here. When we talk about a 45, 45, 90 triangle, what I do know about a 45, 45, 90 triangle is when the base angles are the same, what can you tell me about their side lengths? Well, it's an isosceles triangle, right? So these side lengths are going to be equal. So say I make those side lengths 1 unit apiece. What would the hypotenuse be? So, well, you already know it's the leg times the square root of 2. But here is why. Okay, so if our side lengths are the same and we need to find the hypotenuse, we could use the Pythagorean theorem. So 1 squared plus 1 squared would be the hypotenuse squared. And so 1 plus 1 is equal to 2. And x squared would equal 2. If I square root both sides, that x value would equal the square root of 2. So this would be 1 square root of 2. Now, if I change that, I made the side lengths 2 each instead of 1. We could say 2 squared plus 2 squared is equal to x squared. That'd be 4 plus 4, which is 8. And if I were to square root 8, and I would simplify it using simplest radical form, it'd be the square root of 4 times the square root of 2, which would be 2 square roots of 2. So then the length would be 2 square roots of 2. So if both sides were 3, the hypotenuse would be 3 square roots of 2. So with that, we have this general equation that the hypotenuse is always the leg times the square root of 2. But that's why, because we use the Pythagorean theorem. And we have an isosceles triangle because the sides are equal and the base angles are equal. It works out really well. So we are going to do a couple examples of these isosceles right triangles. So now let's find the exact value of x. Okay, well, we got to know what sides are what. So first of all, I want to just mention that this one is the hypotenuse and these are the legs. Okay, and this is 45, so we know this is 45. So we know both of these values are the same. So we use that formula. Hypotenuse is equal to the leg times the square root of 2. So what's the hypotenuse? Well, it's 8. What's the leg? We don't know. It's x. So how do we solve for x? Okay, we're solving. We're always solving in algebra. So these two things are being multiplied, so we're going to divide by the square root of 2. Now we have 8 over the square root of 2 equals x. Now remember, chapter 4, no radicals allowed in the bottom of the denominator. In the denominator. So we have to do what's called rationalizing the denominator. So we need to take and multiply the top and the bottom of this fraction by the square root of 2. 8 square roots of 2 over the square root of 4, which would be 2. And 8 divided by 2 would be 4. So the legs would be 4 square roots of 2. Because 8 divided by 2 is 4. That's how I got that. Okay, so you've got to use this general formula. Okay, this one says the hypotenuse is equal to the leg times the square root of 2. Okay, well, hypotenuse is x. We know this one's the hypotenuse because it's across from the 90-degree angle. The legs are 3 times the square root of 2. Now we're going to take that times square root of 2. Now we just learned this in the last chapter. If we have the square root of 2 and the square root of 2, and they have the same index, we can multiply those together. 2 times 2 is 4. Okay. And then what is the square root of 4? Well, that's 2. And 2 times 3 would be 6. So the hypotenuse would be equal to 6. Okay, again, we're using that general equation because we know where that came from. The hypotenuse is equal to the leg, one leg times the square root of 2. Okay, another special right triangle is the 30, 60, 90 triangle. These are special triangles, and so they have special rules. But you're probably, hopefully, wondering why. Because I can tell you there's rules, but if you don't know why these rules exist, most of the time you're just memorizing them and you don't really understand. So here is the why. All right, so let's take an equilateral, equal angular triangle. Equiangular means all the sides are, or all the angles are 60. Equilateral means all the sides are the same. Let's call them all 2. Okay? Now, if you bisect one of those angles, okay, let's bisect this top angle here. I bisect it. This is no longer 2, but this side of the triangle is 1. We know this makes a 90-degree angle when I bisect and drop the altitude here, 90 degrees. This is my hypotenuse because it's across from the 90-degree angle. Okay, so we know this angle is 60. We know this angle is 90. Now if I bisect this, this angle is now 30, not 60. So we have a 30, 60, 90 triangle. Okay, so if I pull that 30, 60, 90 triangle over here so you can see what's happening. This is 30, this is 60, this is 2, this is 1, remember, because it was 2 and we cut it in half. This is 90, and we want to find this side length. Guess what we would use? We would use the 30, 60, 90 rules, if we know the rules, but we would use the Pythagorean theorem since we don't know the rules yet. So yeah, I guess we know the rules, they're right here, but if I didn't know those, I would use the Pythagorean theorem. So, long leg is already always across from the 60. The short leg is always across from the 30. So it would be the long leg x squared plus the short leg, it kind of looks like 31, the short leg 1 squared equals the hypotenuse, okay, which is, I should write 2 squared there, not the h, not the hypotenuse. Sorry about that. So we're going to write 2 squared. X squared plus 1 equals 4. Subtract 1 from both sides. X squared equals 3. Square root both sides, and we get x equals the square root of 3. So that value would be the square root of 3. Now get this. The short leg times 2 is the hypotenuse. Those are always, the hypotenuse is always double the short leg. 2 times the short leg. So if this was 2, this would be 4, and this would be 2 square roots of 3. Because then the long leg is always going to be the short leg times the square root of 3. So these rules are really important, and they're awesome. And if you just memorize them and you don't know the why, it makes memorizing them so much more difficult, okay? So they came about by using the Pythagorean theorem. And we all know you can do the Pythagorean theorem. Okay, so let's try a couple of examples. All right, here we go. I want to find the hypotenuse, and I want to find this leg. Now, which leg is this one? This one's the long leg. because the short leg is across from the 30. So I'm going to label my sides so that I know what I am doing. If I don't label them, then I'm not sure which one the long leg is, the short leg is, etc., etc. All right, so what do we know? We have two formulas. The hypotenuse is equal to 2 times the short leg. Well, the hypotenuse is x, and we're going to say 2 times the short is 4. I'm just substituting in what I know. Hypotenuse is x, short leg is 4, x equals 8. So the hypotenuse is equal to 8. Okay, now I'm going to go ahead and use the other formula. The other formula is the long leg equals the short leg times the square root of 3. Okay, and so we're going to figure out the long leg, which is y, and the short leg is 4 times the square root of 3. So y is equal to 4 square roots of 3. So this guy is 4 square roots of 3. There we have it. Okay, let's try the next one. Get a different color here. Okay, again, label your sides. This is the long leg because it's across from the 60. This is the hypotenuse because it's across from the 90. And this must be 30 degrees, so this will be the short leg. Okay, again, using those equations, hypotenuse is equal to 2 times the short leg. So if I know the hypotenuse is 6 and I know my short leg is x, how do I solve for x? I divide both sides by 2. X is equal to 3. So the short leg would be equal to 3. Now, if we were to figure out the long leg, we would take the long leg is equal to the short times the square root of 3. Long is y. The short, now we know, is 3. Take that times the square root of 3. And we would get y equals 3 square roots of 3 for the long leg. Okay, let's do one more example. We have a triangle, and I want you to find all the missing side lengths. So we know this is 60. So this is our long leg. We know this is 30, which is across from the short leg. We know the 90 is across from the hypotenuse. So we are looking for the hypotenuse, which is h, the short leg, which I'll just call s, and then we know the long leg. Okay, so let's go ahead and find all those side lengths. So we know the long leg. If we know the long leg, then we have to use that formula. Long leg is equal to the short times the square root of 3. Okay, so the long leg is 5. So 5 equals the short leg is that s times the square root of 3. We're going to try to find s, so we got to divide by the square root of 3. The square root of 5 divided by this, oh, no, not the square root of 5. 5 over the square root of 3, okay, is equal to the short leg. But we can't have a radical in the bottom, so we have to multiply the top by the square root of 3 and the bottom by the square root of 3. So it would be 5 square roots of 3 over the square root of 9, which equals 5 square roots of 3 over 3. That would be the short leg. Okay, and when they're asking for exact measures, we're not looking for decimals. We need to make sure that we rationalize the denominator. Okay, now we know the short leg is 5 square roots of 3 over 3. Now we can find the hypotenuse, and the hypotenuse is equal to the short leg times 2, or 2 times the short leg. It doesn't really matter which one you put first. The hypotenuse is our h. Our short leg is 5 square roots of 3 over 3 times 2. I can take 2 times 5, and I would get 10 square roots of 3 over 3. Because this is a fraction, 2 over 1. Top number that's the same can be multiplied. Bottom number, 3 times 1 is 3. So this would be the hypotenuse, 10 square roots of 3 over 3. Okay, hopefully this was good review for you, and you took it seriously, as they will be on the ACT and they will be very helpful for our trig chapter coming up. Thank you and have a good evening.